Quite the miracle happened on my last video, which was about the dynamic guitar, my electric guitar with no pickups. I mentioned that it had been patented by a couple of guys at MIT in '78. Somebody contacted me who actually had one of these things that he built around 76 or 7. He's in my comments on the other video. It's totally amazing. This guy has to be one out of about 100 million people. How many can there be of these? 3, 4? And wow. So I was very impressed, and he was familiar with the guys, the patent guys from MIT. He knew about that one. He said he was there then. In this video, I'm going to give you the whole schematics and all that stuff for that one. Because I had so much interest in that video. People actually do want to make them. Now, according to him, it didn't work very well because he was losing sustain. It stopped the string. He was getting dynamic braking on the string, which means his magnetic field must have been much stronger than mine. And he could have used a higher impedance input to limit the current. That also would have limited the force, but also he had different direction magnetic field apparently, because he was talking about string pull from the magnetic field. None is visible on mine. And you know, as you can see, the magnetic fields that go straight across the strings, they go through them like that, fretwise, and they are the same on both sides. Totally not noticeable at all that I'm getting any sort of drag from the current that's going through there. And this has transformers, so whether it's plugged in or not, current is allowed to flow. But I can't tell any difference at all. So apparently mine works better than theirs, and I recommend it. But here's the deal, which I found out by this guitar. Not this one, but the electric version. A string, when you press it on the fret, no longer goes around in circles. It starts going like that because the motion is limited. It's right next to the next fret if you give very low action, and so it just can't go this way. And so you can't have the magnetic field go that way or it won't work. You can't hear it. So the magnetic field must go north-south or north-south, whichever. At any rate, we're going to listen to this thing. And the fact that you can switch it from a 12-string to a 6-string. But it is the most well-mannered, controllable acoustic possible. And, you know, I'm plugging it into this terribly hot rod little tube amp. It's so hot that it's about to get a tube microphonic. I have to do something about that. Change some tubes. I turn on the boost. I don't think you can do that with most amplified acoustics. Not that I'm going to play lead on an acoustic 12-string, but some people do. I don't know. Some people use acoustic guitars. Now, I have a future project. I have a way to make a guitar like this. Acoustic guitar, but make it so when you go like that, it'll sustain the note forever, like a Sustainiac, but no amplifier. In fact, Sustainiac guitars already do that. I have a Sustainiac Fernandez, and if I play it with no amplifier, it'll sustain forever because it's got a built-in motor and pickup, and the pickup feeds the amplifiers, and that feeds a motor. Well, I would use a different kind of motor. I would use the dynamic kind with the strings and the magnets like I already have, and feed the strings amplified sound from a Peizo. And I have the bridge to do it. I don't have the acoustic guitar to do it with yet. That would be a very interesting project. Now the Sustainiac does it at an extremely low level. It's not fun. But with mine, I don't have the limitations of theirs, because they're using a magnetic motor which can get picked up by the magnetic pickup if it's too strong. I don't have that limitation. I could pump a couple of watts into the thing and just make it want to just burst into song by itself. And that's what I want to do. But that's another project. Let's plug this one in. I made my point, huh? Now, let me show you where the magnets are. This one has a field that loops around this way, through here. And here's my neck pickup. And then I wanted a little more treble out of it, and I placed these under here. Now, this is how you manipulate the tone on a pickupless dynamic acoustic. You notice how, oh my God, this, you just can't ask that of an acoustic with a regular magnetic pickup in it. It's just wild. And now, this thing, this license plate, covers a bunch of transformers. And that's all that's in it. That's all that's in it is transformers, because I'm lazy. And I just plug it in to this little linear booster. I call it a glory box. And I made them. And they're nothing but, get it out of there because I got the battery switch in the plug. It's a one transistor affair. Now, you know, it's just a booster. It's got a gain of about, like a gain of 100 or so. Here is the ground wire. Oh, it's still got all that. Connects all the strings together. And it runs right down the back of the neck and into the license plate, where it grounds the ground side of the transformer. See, it's got all the wires going to the strings. They're all connected to a transformer input. But before I did it, I paired them off so that if I switch off 6 of them, it won't make it hum. You know, it's still got canceling. They're in pairs, like, I'll show you the pairs. I don't want to pair this one, these two, because if I switch off the 12-string effect, I switch off 6 of the strings, I don't want it to start humming. So this fat one is paired with this fat one. One here, one here, one here, one here. And yeah, they have to buck hum. And that's what the transformers do. Now, I'm going to show you what transformers I used, because they're the same ones I used for the electric that I did in my last video. I hope you've seen that one, but if you haven't, you can. But I needed to show you magnet placement, because this is the fun part. And really, it takes 6 people, because the magnets want to fly all over the room. They're repelling each other. And they, you know, you got to try to, I glued them down. But you need somebody to hold them down while you play it and see where you, see, I like the tone. So it takes about 6 people, and I had 1 person. Crappy 12-string. However, when I bought it, it had a damn good idea. Somebody had done a little cutting up in there. And I changed it back to regular for this project, but you know, it was really good when it had octaves all the way. It had, like, all the way to the top was octaves, and then instead of going up, it went down for these 3 strings. Better like that. But I have to find a good source of that gauge of string. All right, we're rolling. And I have today got lucky. Not that lucky, because it's the day after Christmas, and all I got for Christmas was a lousy case of COVID. But I found one of my little amplifiers. And I'm going to show you this up close. Real close. These are they. It's a transformer. And, you know, I needed low impedance input. But the only ones I could get were the ones I could get. So these are, they look like this. There's an iron core and a secondary. And the primary is center tapped. But that meant nothing to me, because if only the secondary had been center tapped instead. Because I'm using the secondary for a primary. This is the 14 ohm side. Now, these are the ones, I just got them on eBay. They're little output transformers for transistor radios. The primary is a 1K center tap, so that 500 aside, but I'm not using the center tap. I'll show you the whole circuit now. But first, let me go through regular transistor circuits like I was taught in school. I was sitting there in class, and believe me, I loved electronic school. It was like, thank you, you told me. Before that, it was a big secret. Nobody would tell me. My parents didn't know. Ugh. Nobody at my school knew. Nobody knew. Here's your typical single transistor small signal amplifier. You can see them all over YouTube, and this is how they taught me. We're going to go from here, and we're going to attach a transistor. And we're going to have an emitter resistor, and they call this the emitter swamping resistor. Coupling. So the way we would calculate the so first of all, this junction, if you don't have an emitter swamping resistor, oh, you can do that. I have done it. Hell yeah. Now, it gives very high gain, but very poor linearity because this function is unpredictable. The junction right here is going to have behavior that is characteristic of that transistor. We don't want to let the transistor's characteristics determine the quality of our signal. We would rather have resistors do that because they're so nice and linear. We're going to put in an emitter swamping resistor so that it's more predictable. And then, because this current string is the only way it can go, there. The current is equal going through here and through here. Almost equal. There, 1/100th of it is the forward current transfer ratio beta. We're going to neglect that for a minute. It's only 1%. So basically the ratio between this resistor and this resistor gives us our gain, our voltage gain. Because this gives negative feedback. As the voltage, current goes through it, develops a voltage drop, makes this point get more positive, which would need more positive voltage swing here to turn it on. So then they want you to do this, I was taught. We are to compute the input impedance by just doing this resistor in parallel with this resistor and neglecting the current through it. Wrong. Wrong. That is so wrong. The first thing I did was, why waste, right? I'm not a wasteful person. I try not to be a wasteful person. So I said, why are we doing that? And I quickly did this, which is, I got rid of that one. Now, all I need to supply to turn this thing on is enough to get through here. It turns on. This thing is very high. Now I can neglect this, and I can calculate the input impedance of this. And I'm not wasting power because I cannot be throwing away power. And the way we're going to get the best power transfer is by impedance matching. And I can prove that, and I will prove it. Excuse me, forgot the emitter resistor, which I have, and of course the load resistor, without which it will not work. Here are the values for the amplifier I'm using in the thing. Now, first of all, let me draw in the transformer. Yes, we have a lot of noise from this big resistor, and look what happens to it. It's shorted right through the ground. So much easier to see with the dark pen. There is not enough inductance in here to block any noise. We're talking audio frequencies here. And this capacitor is big enough to be totally out of the way. This 13 ohms, after beta is considered, it's going to look like 1300 ohms at this point. And that's going to, a 1300 ohm output will give me about a 17 or 18 ohm input here because it's reflected right through the transformer. Transformers are very good about that. You know, when you plug in your wall adapter, it's not supposed to draw appreciable current unless you have it plugged into your thing. Now, we know that when you plug those things into the wall, they get hot. And that's why, if I want 9 volt, I will buy an 18 volt, 220 volt, and I'll plug the 220, I'll cut the plug off, and put a 110 plug, and I will plug it into the 110 because it's got more windings. It was designed for 220. Now this is an engineering decision. They thought, well, we need that for 220. Well, it runs much cooler. The 220 to 18 volt works just fine for 110 to 9 volt and stays much cooler. They're scrimping on wire. And you know, it's simply a design decision. But transformers, when you draw more from the secondary, they draw more from the primary. And conversely, you open the secondary, it should draw nothing. It doesn't draw nothing, but it should. When you're not using a transformer, you simply do this, which I do all the time. Blocking a coupling capacitor. Now, let me talk about noise, because it's an issue. That we're in the business. We got to reduce noise at all costs. And now, noise is a characteristic of resistance and cannot be gotten rid of. There has been a lot of talk on, I'm sure it's in your feed too, about the $30,000 phono preamp. And of course everyone thinks, oh, that's too much money. And yeah, of course it is. But then I thought, well, how can we really improve on that thing? And you know what we can do? Transformer input. I don't think it's ever been done before. I've never heard of it. I've had a million phono preamps, including Marantz, and nobody had a transformer in there. What a great idea. I used to have some cinema transformers that were 100 to 1 turns ratio. You know, they apparently thought it was worth a sacrifice in fidelity because you're not really supposed to go past about 10 to 1 for audio. According to Dick Jensen of Jensen Transformers, he made a great product, and he blew his brains out. And we don't know why. He might have had health problems, or I don't know what his problem was, but we're sorry. Anyway, he said 10 to 1 for audio is about the best you can hope for. But these were 100 to 1 transformers, and you know, I guess in cinema, you don't know what you're going to be recording, and you want if a fly comes, you want to hear it. I'm suggesting 10 to 1 transformers for a phono cartridge. I think it is such a great idea that I have to try it myself. I have a phono cartridge and I have some transformers. I'm going to build, now if I build a phono preamp, this is going to be 10 dB better than all the other phono preamps in the world, because see, we're all running up against the same noise problems and we're all using the same stuff. And you know, the best mics in the world, well, they're using either multiple op amps, which is very rare, or like a Neumann, they just use a FET. Well, let me tell you, if microphones could be quieter, they would. And I have a way to make them quieter. I'll share that with you in a different video. See, I don't like to do the little incremental, you know, oh, I'm like a quarter of a dB better than anybody. No, I want 10 dB better than anybody else. And a transformer would give this to you. You know, I think it's just a matter of money, that a phono cartridge is a consumer item most of the time, and they didn't expect that audiophiles were going to want to pay ridiculous amounts of money to get a marginal improvement. But I can give them better than a marginal improvement. I can give them a vast improvement. Now, the reason we can't do that for microphones is that a microphone cartridge is extremely high impedance. So, great, we run it into a tube or a FET. But a phono cartridge is not. And so we can match it. Let's say we have a battery, and it's got a resistor. It's got internal resistance, and we're going to say it's a 4 ohm internal resistance. And we're going to put this into a circuit, and I'm going to show you how to get maximum power out, and I'll prove it. I'll say 4 volts because it's lithium. So here's a 4 volt battery, and there's 4 ohms resistance, but we're going to put it into a 4 ohm load. And obviously the voltage is going to divide evenly, so we're going to have 2 volts across this, from here to here, 2 volts, and 2 volts across this one, which is wasted, because this is the load. How much current we're going to have? Well, we got 8 ohms, so that's half an amp. So 2 volts times 0.5 amps equals 1 watt. Matching this gives us 1 watt. Now we're going to unmatch it. We're going to say, well, we don't want to drain it that much. Let's let it have more voltage. Yeah, let's say we change it to 12 ohms. So here's your 12 ohm resistor. The voltage is going to divide. Now we have, hey, you've got 3 volts here. And you only have 1 volt dropped across here. Sounds great. How about current? Plus 4 is 16. I could do that one. That is 4 volts over 16 ohms. That's a quarter amp. So now we've got 0.25 amps times 3 volts, giving us 0.75 watts. It's worse. It's worse. Isn't that terrible? So sometimes saving that little bit of, mental stress, thinking, oh no, I'm soaking it all up, or match it. That's how you get maximum. And the same applies the other way. If I had 1 ohm here and I let more current go through, great, but I get less voltage. And when you match it, that gives you the maximum. So that's what we want in this case. We're trying to pick up a signal off something that's very delicate. And so we want to match the impedance to get maximum power transfer only if we're able to utilize it. Now in a vacuum tube that is, I want to say common emitter, common cathode, now they should really be called emitters, but they call them cathodes. So in a common cathode, it's high impedance input. And that's why they go ahead and use a transformer. But there are circuits that are not high impedance input. I can show you those too. A common base circuit. And I actually made one. I've never gotten it working yet. I made this tube preamp. This is a mic preamp. And it is all tube, but it's low impedance. It has no input transformer, and yet it's low impedance because it's common grid. And I couldn't get it working. I found out later it was one of the 12AX7s was dead. It lit up, but it didn't talk. So this happened to me in electronics school, and I just thought, oh, what the hell's going on? And it was the tube. So in this case also, and of course I changed the tube, but I'm busy. So I have to try this out sometime. The thing about common grid is the grid's grounded. So it's very low noise. And it's low impedance because you're putting your input in at the cathode. And so you have to change that current a lot to get any voltage swing out of the tube. So low impedance input, very high impedance output, a lot of voltage gain, and very low noise. But I never lit it up yet. I will. I'm going to do it for a YouTube video. That's how I'm going to beat the $30,000 phono preamp by a factor of 10. And then I just need to put the little RC network for the RIAA curve. And I have that around here. I have plenty of stuff to look at to get the right time constant. But am I done? Well, not really, because I have this idea. You know how I just love it when the guitar sings by itself, and you play an acoustic guitar. It's kind of disappointing because you pluck the string and it dies out. That's no good. Well, I'm going to make a guitar. I haven't made this one yet. I guess I'm looking for the right acoustic to do it to. I don't have it yet. But I need to start making the electronics. I have here a Parker bridge, a Parker fly bridge. And they have individual Peizos. See, it's got a tremolo bar with individual Peizos. So, wow. But I want to put this on an acoustic guitar. Oh yeah, I'm going to have a tremolo bar on my acoustic guitar. This acoustic guitar, see, I don't like the sound of Peizos. I'm not going to hear them. They are going to power amplifiers, which are going to feed back into the strings. Now this has no speakers. This is an acoustic guitar, so don't worry about what it sounds like. It sounds like when you play it. But it's going to be powered. And so these are going to feed amplifiers that go directly into the string. And these amplifiers don't have to be zero bias. They don't have to sound good. They could be halfway. It doesn't matter. So I really want to try that. And I'm so lazy. But I know how to do it. So after I do that, everyone will need one.